In this episode, we will talk about how to mimic human metabolism in mice.
For example, neurons, glia.
Let's talk pharmacokinetics for antibody development.
Following the transplantation of hematopoietic cells.
Let's talk how to test if your drug induces a cytokine storm.
Welcome to JAX Tech Talk with the technical information scientists of the Jackson Laboratory.
My name is Neeraj Tiwari, and my role as a technical information scientist is to serve the research community with education and practical solutions. JAX Tech Talk is a 15-minute chat that may be of interest to anyone in preclinical research and drug development. So for today's show, we are going to talk about services to consider after generating a new mouse model. For anyone watching live, use the comment section of the video to share with us any related questions you have. We'll try to answer those live. Today, I have my colleague, Peter Kelmenson, on the show. Peter, could you please introduce yourself to our audience?
Thanks, Neeraj. My name is Peter Kelmenson, and as a scientific engagement manager here at JAX, I work with researchers and scientists around the world with help with model selection, model generation, breeding, and any of the services that JAX offers to researchers.
Thank you very much, Peter. It's great to have you on the show today. So for all of you who are new today, we have done many of these tech talks focused on generating new mouse models. I would highly encourage all of you to revisit these talks when possible. My first question for you, Peter, would be, when we are talking about new mouse model generation, what are the technologies we are talking about?
So first off, we're talking about CRISPR-Cas9, which is the technology that we use most frequently here at JAX for generation of new mouse models. More older technologies like targeted mutagenesis using ES cell lines, transgenesis with pronuclear microinjection are also technologies that are still commonly used by researchers. And the Jackson Laboratory does provide service offerings for all of those technologies.
So we know that out of all these model generation techniques, CRISPR is very efficient and takes less time to generate new models. You can create mutations in mice on any background, which saves a lot of time wasted in backcrossing required for other model generation techniques. Many companies are providing CRISPR-generated mouse models. How would working directly with JAX for CRISPR model generation be different?
Yeah, so costs would be expected to be higher at JAX than an academic core lab, since those labs are heavily subsidized for campus research. But JAX does offer additional off-the-shelf services and product guarantees that carry a lot of value when considering the long-term security of your mice and project. JAX covers the entire process from design through reagent prep, genotyping validation, all the way to confirmation of germline transmission. And because we cover all of this, we can offer the kind of guarantees that core facilities cannot. So if we can't make the model, you're not going to pay. And also the models that we do generate come at a high health status, allowing direct delivery of those mice into your facility without requiring any sort of rederivation.
So thanks for explaining all the additional services that we provide here at JAX so that our customers don't have to worry when they are creating new mouse model with us. So even if you are a novice about model generation and want to create a new mouse model with us, we have dedicated project teams that will guide you from beginning to end. So let's move on to the next section of this talk, which is about once you have your new mouse model, whether made at JAX or elsewhere. Peter, what are the next steps for researchers once they have the new mouse model?
Right. A lot of things that you need to consider and really plan for. But first, you're going to need to breed those mice to expand your strain in order to generate enough mice so that you can validate the model. The process and how long it's going to take is going to vary widely depending on the specific model that you have made. You could be expanding a transgenic mouse strain, you could be producing homozygous mutants, or you could be crossing to other existing mutant or transgenic mouse strains to generate some sort of compound mutant or transgenic strains. So for example, let's say you've generated a LOXP flanked allele so that you can make a conditional knockout. Those mice, you're most likely going to need to cross them to some sort of Cree-expressing mouse strain to generate the mouse model that you need finally to validate. And then once you actually have validated your model, then you're looking at additional rounds of breeding to expand your colony to start producing cohorts of mice for your actual studies. At that point, you also should really seriously consider cryopreservation of your new model to protect your investment of resources and time against any number of potential disasters.
So whether it's breeding the new mouse models to generate homozygous mutants, to generate cohorts, or cryopreservation to protect these mice from disasters, how can Jackson Laboratory help researchers with these steps and reduce timelines?
Well, first, Jackson Laboratory does offer breeding services. So we can breed your mice for you, generating the cohorts that you need for model validation and for studies. We also offer IVF expansion services that can reduce the time that's needed to generate those cohorts of mice. And finally, Jackson Laboratory can cryopreserve and then store the frozen sperm or frozen embryos of your new models to protect you and potentially help you with additional plans if you need those mice at a later date.
So Peter, this is a question that often comes up. So as a PI, you have developed a new mouse model, which can then be used for development of target therapeutic. So now you're looking at working with pharma and biotech to expand upon the work done by the lab. So what are things you should be careful about, especially related to breeding mice and how JAX can help them?
Yeah. So the health and the genetic quality standards in industry are typically much more rigorous than, say, in academia. You may be asked questions by your industry partners about strain management, security, biosecurity of your strains. And with JAX, we can help you to address those concerns by implementing some of the services that we have touched on. We can cryopreserve your model, thereby protecting those resources. We can genotype the mice to make sure that they have the mutations that you want. And then projects that are going to require larger colonies could recognize an easier or faster path to success by using the Jackson Laboratory for breeding or IVF expansion services. And what JAX can do is we can provide you with the vivarium space, expedite the colony expansion, and offer globally recognized technical expertise when you or your industry partners see a need. And especially when it comes to running a study, often you need large numbers of mice, and that sometimes can be difficult in an academic research facility to produce enough mice to run a study for an industry partner. And we have that space and the resources to help you generate those cohorts so that you don't need to waste your time or spend your time producing those mice that are going to go off to your industry partner. You can have us help you with that and make that process smoother.
Thank you, Peter, for explaining that details. So let's take some questions asked by our viewers today. So I see, okay. So I see one question about IVF. So Peter, the question is how IVF can shorten the timeline.
So that's a really great question, and it can be a little bit, try to do my best to explain. So let's take an example. So let's say you created a point mutation knock-in, like change an amino acid in a gene, and you need to produce 50 homozygous mutants to run a study. You've just got the model made and you only have a couple mice, say a couple males. So with a couple males or frozen sperm, we can use that sperm from either the males or the frozen sperm to do a large IVF using wild type females that we already have in stock as the oocyte donors, and then generate enough live born heterozygotes to then breed het by het to produce 50 homozygotes. And we're talking about 6 to 7 month time period to do that. If you try to do that with natural breeding, where you only have a couple heterozygous males to start, you've got rounds of breeding to start to expand to get enough mice to get you, so you could be saving 3-6 months of time by using IVF.
Yeah, thank you, Peter, for explaining that. So I have next question, which asks about like, who do I contact if I am interested in generating a mouse model with JAX?
Sure. You can visit our website, and there is a custom model services inquiry form on the JAX website. You can enter the details of the model you're trying to generate, and that will go to our experts, who will contact you probably to schedule time in which we can set up like a video conference to discuss your research goals. I'm often that person actually who does a lot of those, but to figure out what model you need and then what JAX can do, and talk about options and timelines and costs.
Okay, thank you, Peter, for explaining that. So the next question we have is, I'm working with a mouse not currently available through JAX. Is there still a way I could use mouse model generation service to modify the strain?
So the answer is it's possible. It really depends on the model. If it's like a unique inbred background and you want to make, say, a mutation in that unique background, there's going to be a little bit of risk. We'd have to be able to import the strain into our facility, and that involves a rederivation, then breed the mice to expand a colony to get enough mice to produce the embryos for CRISPR-Cas9. And if it's a background we don't have experience with, we can't be sure that it will work. So there may not be that guarantee. If it's a model, say you have like a triple homozygous knockout on C57 Black 6 and you want to add a fourth mutation, then, we're looking at potentially, again, the same sort of process. We'd bring in your strain, rederive it, build a colony, but because we can do CRISPR-Cas9 on Black 6 mice, you may have a better chance of success. But there's still additional time, because we'd have to breed those mice to get enough to do the CRISPR Cas9 to do that mutagenesis. But if this is something you're looking at to do, absolutely bring it to us, again, using that form I just mentioned, because then we can have that consultation with our experts to help figure out what is the model you need and what are your options to figure out what would be the best option for you.
Okay, so we can take one more question. So the question is, if a mouse model is created under the highest barrier, would it be difficult to house it in standard housing?
I don't think so. I mean, it may depend a little bit on the model. So if it's an immunodeficient mouse model, like it has some sort of immunodeficiency, if you move it from a high barrier to a standard housing, there could be more opportunistic organisms present that could cause health issues. But for most strains, going down to standard housing may not cause any issues. It's more like at JAX, we try to keep our mice at as high health status as possible to facilitate importation into researchers' facility without having to do any sort of quarantine or rederivation. But they certainly can often be housed at a lower health status than they start.
Okay, great. So that's all the time we have for this week. Thank you for joining us. Our next Tech Talk episode is on Swiss outbred mouse diversity, which will be live on Thursday, July 20. Follow JAX Tech Talk on LinkedIn so you're notified anytime we have a new episode, or subscribe to our playlist on YouTube and catch all our previous episodes. So this is Neeraj and Peter saying, stay healthy, stay safe, and stay excited about your research.
Thank you, everybody.